So I think we will have a online meeting, okay, for all of you. And for the first one, I think let's welcome Gwen and Rohak, Elsa, and Jiankai. And before that, I would like to take a picture of your group first. Oh, where is okay? Okay, so come here. It's final presentation. It's a little bit strange on your face. The cheese. One more. Okay, good. Go ahead. Okay, someone can control.
Hello everyone, my name is Tim, and those are my teammates. And this is our content. And our purpose is monitoring the slope located behind a zero dome to check that if it is stable or not. And there are 5 parts. And this is our sensor. And we choose the sensor based on useful and range, resolution, price. And the first one is CHIH-CHUNG, and it is for air temperature and humidity level. And second one is FC28. It is for soil water content. The third one is GY521. It is for vibration, movement, and displacement. The last one is SW420. It is for vibration. And those are their information like cost or resolution and range.
Also, for this project, we needed a way to get the data from the box, the Arduino box, to the computer. So at first, we wanted to use the SD card and the LoRa system, but we found that it was impossible to use the SD card with the LoRa system, but it will be explained later. So here is a quick overview of our communication system. The information goes from sensor to Arduino, then from Arduino to LoRa antenna connected to the box, then to LoRa gateway on the roof, which is sent to Node-RED and ThinkSpeak to visualize and to process. This is our final circuit. It is composed by 6 elements. The first one is the accelerometer, which is functioning with a bus, and we can adjust the sensibility. Also, we have the moisture sensor. In practice, the range of the sensor between the data we received was from 330 to 1023, but we calibrated it to get a percentage. We also have the vibration sensor, which is 0 or 1 if we have a vibration. Also, temperature and humidity sensor, and the communication system. And this is the way we implemented our system. So we put it in a plastic box that you can see here. We related it with a scotch to assure that no water is coming into. Also, we needed a power supply, so we used a battery that was provided, and we also connected it to the solar panel. And to put the soil moisture sensor, we add the rod, and so the cable will be safe.
Okay, now I'm going to talk about some problems we have had during the project. So the first problem was to use the SD card with the LoRa. So basically, we wanted to have the SD card and LoRa, because if we don't have a signal because of, I don't know, we can receive with you can have data with the SDK. So the figure is the same. We had a real-time clock here and a SD card in addition. So the purpose of the clock was to have an idea from the time, and if we collect the data with the SD card. The first problem we have in this project was to use the clock and the accelerometers because both use the I2C bus and they have the same address. So to resolve this problem, we have an option with the accelerometer is to use this pin, forgot the name of the pin. But if we put 5 volts in this pin, we can change the IP address from this one. And thanks to that, we can have 2 different IP addresses. So this part we can resolve, but the big problem was to use the SD card and the LoRa. So we don't know exactly what is the problem. Theory use the other bus in the Arduino, so the LCD-A, and we have the master of the Arduino card, the 2 slaves. One is the LoRa and the second is the SD card. I think when you want to communicate, the slave has to put tension, low or high, and I think with the LoRa we can't do that. So I think it's the problem, but I'm not sure exactly why. The second problem was about pin speed. So when everything was done, when the code, Arduino code was done, and we were able to see it with MQTT, we were trying to use pin speed, and we received this kind of data. It's a delay of 10 seconds. So you see for the first parameters, we have about 20 points for the temperature, but for the accelerometer, we have 2 points, 2 points, and 6 points above. So we tried to increase the delay and the Arduino card from 1 minute, 2 minutes, but it was always the same. We had always this kind of figure. So we find a solution because according to the website InSpeak, because we have a free version, we have to wait 15 seconds before sending a new message. So you can set the temperature, you have to wait 15 seconds, and you can send humidity. So we decided to increase the delay in the Arduino card about 2 minutes, and we put a sub delay in the null way from at least 15 seconds, so we choose 17 seconds. So now we can set the temperature to pin speed, then we have to wait 70 seconds before sending to humidity. And thanks to that, we were able to receive this kind of figure. It's exactly the same number of points. And I think with this kind of method, we can receive almost everything in ThinkSpeak. We can receive in MQTT, we can receive almost 100% of data. Project and the stuff. We have had 2 breaks, one on Sunday and one on Wednesday. And each time it was at the morning, the beginning of the day, so about 5:30. I think this one was 5:24, this one 5:28 p.m. Each time the doesn't move, there's an antenna around the box. And I tried to check the big antenna at the top of the building. The big antenna was okay as well, so it wasn't a problem about the antennas. And each time Arduino card, sensor, and the battery was still running, so it was here. And each time it appeared in the morning, they were in very sunny days. So on Sunday and Wednesday, the other day was quite cloudy. And it was when the sun was positioned to charge the battery. So we think we have a problem with the battery and the solar panel when we try to give some current to the battery. We have a problem. So that's why we say to turn off the solar panel. And it was okay.
So here you can see the data for the temperature and the humidity. So we had an issue on the 19th because the antenna was at full, and by the time we got the issue cleared, this part of the graph has no available data. But as you can see, the pattern is like 24 hours. So during the night, temperature lowers. During the days, temperature rises. And you can see the opposite for the humidity. During the night, the humidity goes up, and during the day, it lowers. And so we did the correlation between the two, and the correlation coefficient is pretty high. It's like 0.82. So you can see a good correlation between both of them. So that's for the air temperature and humidity. Then when it comes to angle data, as you can see, we have two issues. So that's the issue Gwen was talking about. So with the solar panel here. Yeah. So as you can see, there is a slight increase in between the two breakdowns, and that's because we manipulated actually, this is not really real variation. So actually, with the noise, there's no real data to be acquired from that. And also from the data before, the data we saw is very typical of Taiwanese weather. It's humid and hot. Yeah. So here there doesn't seem to be any issue also with the angle. So then, when it comes to soil moisture and vibration data, we had more issues. So here you can see the breakdown because of the antenna that fell. So for the soil moisture, before the 90s and the breakdown, it seems all right, like between 80 and 60 degrees of soil moisture, and going down because summer tends to be hotter and drier. But then here it's completely broke down. It's under 20%, and that's like a very typical case, which is very it's not possible in Taiwan. So this is not possible. So the fact is that the sensor was broken. One piece was broken, so it didn't work anymore after the breakdown. And for the vibration, it feels also very weird. This part, like almost we have no data that we get. And then after this, we took a look at the sensor, and with a bit of vibration, a bit more vibration, a lot of vibration, and like this goes to like 100 and 150, and that would be a big vibration. And so that's not possible because we would have seen something on the slope. So we think that there was some issue of connecting issues. So the vibration was not very successful either. For the rainfall data, we chose not to buy a rainfall capture because it's quite expensive, and we can find some pretty accurate data from better sensors that already exist. And so what we chose data from a senior high school near the NTU. And so for a very small period, we did not have enough data to see a very conclusive correlation between the rainfall and the humidity and the temperature. And this is what we expect to find, but it's not easy to find, and the data is very simplistic. So we need like very large amount of data to see any correlation. So we didn't have enough. But we can see on this day, I think it's the 14th, we had a peak in the rainfall data, but otherwise it's rather dry on this period. So as a conclusion, so we can see that we had a lot of improvement to do. So the first improvement would be with the solar panel, which should have worked but caused issues. The second improvement is with the SD card. Maybe there is a way to have an SD card within the LoRa, but we did not find it, so that would be the second improvement. Lastly, we regret a bit the quality of the captors because the vibration captor and the soil humidity captor did not work and broke down. So we would have, if we were to do it again, we would show them better captors. And lastly, we had some issue with the data that we wouldn't receive the data, so we had to fix that. And so maybe we would think that a Wi-Fi router or a 4G router would help us to get safely the data from our location to a safe space. That.
Okay, thank you. Okay, I have it's very good, but I have very quick questions. You said that you calibrate the soil moisture from the reading to the 0 to the 100. How did you do that?
I took a glass of water and put the sensor in the glass
Yes.
of water.
Okay, and in the air. Okay.
Just nothing to in here. So.
I mean, it's, you put it in the air and then in the water.
Yeah.
Okay. Oh, I see. See, it's very good. Okay. Thank you very much. Okay. Let's move on to the second one. So let me see. So. Here, this one?
No.
This one? Yeah. Hey. 你们是这一组吗？哦 ，OK。So this one？ 最后一个，Okay. Okay, and again, before that, 我有在录影，所以你们可以这样子。对对对。So, take picture first. Okay. Okay. 1, 2, 3. And okay, thank you. So go ahead.
大家好，那今天这是我们的我们要做的一个简报。那那边是我们的组员，那我是卢政伟。那这里是我们的大纲，他会先做一个简单的简介，然后我们监测的斜坡的介绍，然后整个我们所设置的系统，然后结果与讨论，还有一个结论的部分。那监测系统呢，我们大多是由好几个传感器它所组成的，那可以用来获取各种我们所需要的数据。那并且呢，我们可以经过分析这些数据，可以了解这些监测目标它随着某些特性随着时间的变化。那在大多数的情况下，我们可以借由预测这些灾难，并且做到一个预防的动作。那也可以让我们更加了解到灾害的原因，然后对灾害有更加的了解。那我们这次报告的的地方呢，是为我们学校校业街后门的停车场。那这个这个坡面它的下方呢是有很多车位的一个停车场。那如果这个斜坡它是处于一个不稳定的状态的话，那如果发生坍塌的话，那会对人员造成一个伤害。所以我们所以我们需要对这边做一个监测的动作。那所以我们在这边安装了一个带有许多传感器的一个系统，那可以监测这些数据，然后再加以分析这些数据。那这边这个就是我们研究的地方，那它是由许多岩石跟植被所组成的。 那它的高度约为8公尺，那长约15公尺，那它大概是一个坡度约为26度的坡面。那它就是在地图中我们的地方。那我们将整个监测系统安装在一个具有太阳能板的天线的盒子中。那它可以将它可以将数据发送到我们 LoRa 系统，然后最后呢，我们可以再用 SimSpeak 来分析它们。那在这个项目中，我们将所有的传感器安装到一块Arduino 的板上面，那再连接到太阳能板上的外部电池来供电。那在这个项目中，我们选择了5个传感器来使用。那它每个都有对这个坡面有一个可以监测的目标。那这个就是我们的这个装置的一个图。那大概就像这样子。那第一个的话是加速度计，那这个传感器它可以捕获在所有方向上的加速度。那借由这个传感器，我们可以知道这个坡面它是否有它有属在移动的话，那我们可以知道它是在往哪个方向上做运动。那再来是温度传感器，那这个温度传感器呢，它可以帮助我们了解到温度。对于了解温度与地面湿度的相关区分呢，会有一个帮助。那再来的话是空气与湿度传感器，那这个与刚才的那个温度传感器是同一个，那它也是一样，可以让我们了解到土壤的湿度和空气湿度之间是否存有相关性。那再来是倾斜传感器，那这个传感器它是使用一个2进制的传感器。那假如这个传感器它是处于一个水平的状态，那它在垂直方向上则为1，那反之则为0，那它可以让我们了解到整个坡面的状态。那再来的话是超声波的测距，那这个传感器它可以发出一个波，然后在障碍物上反射，并且返回到接收器。那这样的话可以让我们可以知道从接收器到障碍物之间的距离。那这样的话也可以让我们查看到坡度是否在移动。那最后一个的话是土壤的湿度传感器。那这个传感器的话，它可以让我们有助于了解到土壤中的水分。那它这前面2个探针的话，可以当可变的电阻。那当土壤是为干燥状态的时候，那它的输出电压会变高。那这个图的话是我们使用的土壤湿度传感器。那我们在开始设置的时候，它虽然是可以运作的，但是很快的我们就发现它出现了一些状况，就是像在图片中我们可以看到，它2个探针上的金属已经不见了。那可能是因为我们所使用的传感器它的质量并不是特别的高。对。
Okay, so that general program is in the file that we sent to you before. So the Arduino program is used to get the data from the sensor, and then we made a port to send the data to the LoRa system through the antenna. Then the data comes into the rooftop, the antenna, the LoRa system, and then we can use it with we can see it with the MQTT network protocol and with the ThinkSpeaks through the not-read programming tool. We can see and visualize the data. So this is the thing that we code for every sensor. We have made a program to get the value and to know which part of the message sent corresponds to which values. So result and discussion. So we had the same problem that the other group. That means that we wanted to use SD card to be sure to have every data, but we never be able to send information and use the SD card at the same time. So in the end, we resolved just to use the LoRa system because it may be more useful to visualize the data in real time. And then we have a major problem with the integration of our system because some of our sensor has to be outside of the box, like the humidity sensor in the soil moisture. So we have to install plastic tube for the electric wire and things like that. And then it was our major problem is that we never be able to send data when the system were in slope. I mean, where we work in the lab, we can send data through the antenna, but when we get close to the slope, the data never send. Sometimes when one or two data can make a way through the system, but most of the time we cannot get any things and still didn't work. We tried many things with the CHIH, and I think we've tried everything, but in the end, we don't know why, but this is not working. So it's quite shame because we spent a lot of time to try to resolve this problem and we never be able to visualize our data. Yeah, and that's why we put our system in the box in the upper right of the peak with the big antenna. And we were able to get few data, but it was like for maybe 5 minutes and then it stopped and we don't know why. We didn't have any results to present. We only get 2 or 3 browser measures every time, but we can't analyze this. So yeah, it's really a shame. So in conclusion, even if we didn't get any data and the system didn't work at the end, we learned many things like how to use an Arduino card, how to use sensor, how to choose the right sensor to monitor the slope. We also be able to learn how to use an antenna to send data with ThinkSpeak, Node-RED, and everything. So even if it didn't work, we learned many things, and I think it's maybe the best thing about it. So yeah, thank you. Thank you. And this is our reference.
Okay, good. So you said when you use the RORA, you can only have 5 minutes.
Yeah.
But after the 5 minutes,
Nothing.
nothing.
Yeah.
Okay.
And during QTT thing, we were able to see like the 1 or 2 first message, and then nothing. And we don't know why.
So where is your station? The lowest station?
In the first part, we were in the lowest station, but we thought maybe it's because the antenna it's too low and the slope is too big. So we tried to put it in the upper end, upper right side of the slope. But even here, we just get few data and then stop. And we don't know why.
How about your experience?
We try with here and we try with our project and it's working. When we switch, then it doesn't work so well.
Oh, so I mean, you can go connect to the LoRa with the shorter antenna. It is okay for you, but not
forever.
But have you ever tried the bigger one antenna?
Yeah, with the big one antenna, we get 5 minutes and then it's stopped. I don't know why. We try everything. We switch every antenna.
So you already work together, but something wrong with your system. It's very weird. I don't know why.
We have
so I think you use the same code of the LoRa, right? I mean, in the Arduino, for the sending the LoRa message, I think all of you use the example of. Because I think the building, the dormitory, in a up slope will be the big issue for transmit the data. I don't know why. Okay.
Yeah, because where we in the lab,
yes,
we get data.
Yes.
Not in the slope. So maybe this is the problem: the distance between the LoRa system on the rooftop and the slope.
But I would like to say the first group is okay.
Yeah, this is why this is very real. Yeah.
So have you ever changed the different Arduino card? You not have tried.
Yes, we change with but I already there are I use the Uno.
Oh,
things.
Uno. Okay.
Yeah. But this is I don't think this is the card.
Ah.
Maybe it's a message needs to picture. The message of here is very long to read. So
Maybe we want to take too many information and get lost in distance. I don't know.
Oh.
Maybe something like that.
Okay. Okay. I see. So. Okay. Maybe we can check out in the future, because I think one problem maybe from the different chip of the LoRa. Have you ever tried to change the LoRa chip?
Yeah, I think we have another version of the LoRa. This one works. I think it's the new one.
Or you already changed to the new one?
Yeah, I think yeah.
Oh.
Yeah, we tried everything, I guess.
It's very real. Yeah. Okay, I think, but it is a very good experience to try to figure out what is the problem. Okay, I think the process is very unique for all of you. Okay, and you can learn from that. Okay, thank you very much. Thank you. Okay. So which one? This one?
Yes.
Okay. Okay, go ahead. Before that, yes, I need to take a picture. Sorry. A little bit. Okay, 1, 2, 3. Okay. Yeah, please.
Okay, good morning everyone. So now I would like to present our final project. So in this group we only have 3 members. So I did for the Arduino system and etc. And then he did for some of the processing, and then she did for the report. So this is our outline. First is a background, and then second equipment. Third is methodology and network construction, monitoring data, and compilation. So this is our background. We think that monitoring is one of the important things to prevent the risk of disaster. And then the project related to monitoring environmental variables are simple and common, but always with great importance, because as we know, we monitor very good thing, I guess. And also for collecting data, we use the IoT system to collect the data. By using IoT, we can collect the real time from sensor, and then the data can be used for the forecasting also. IoT also can be used to collect data from different devices and generating alerts in case of any threshold. So this is our equipment. We use Arduino Uno, and for the temperature and humidity, we use DHT11, and then we use LoRa and GY61, accelerometer, and breadboard, of course. I think okay. This is the methodology of us. So maybe it's quite simple to understand from Arduino, LoRa, and MQTT box, and then to .thread, and then after that to ThinkSpeak. This is our code in Arduino. So first, we should to separate 2 sections. The first section is for the library, and then pin connection, And the second section is for sensor rate and weight the function. And this is about LoRaWAN. I think LoRaWAN also very useful in this case because LoRaWAN is the protocol for wide area networks, so we can get the signal from the field using this LoRaWAN. And also MQTT. So MQTT is like the how to collect the data from the field. And then this is the network connection that we got from MQTT. So because we are the G3, so the group number is G3, and then humidity, temperature in Celsius, and then accelerometer data. And this is our node rate for the image is not good. Okay. So in node rate also we make one system for saving the data because we guess if we use TeamSpeak, maybe there are some delay over there, maybe around 60-second delay in TeamSpeak. So the data will randomly collected. This is our data yesterday. Yes. Yeah. And then if you see the accelerometer data, it is very randomly data, and then it means that we should to filter the data so it will show better. So this is the original data, and then this is, if you see here, actually there are two lines. The blue line is the original data, and then if you see here, actually there is a red line. The red line is the filtering data. And this is our calculation. Monitoring data can be conducted using Arduino and set of equipment depending on its purpose. The use of LoRaWAN and MQTT broker are very convenient for data communication with long range and real-time monitoring system. ThinkSpring.com as the analytic platform provides a good data visualization first. During the monitoring process, the error data occur when uncommon or impossible data appear. Therefore, the user still needs to correct the data by filtering. The error data maybe comes from the sensor, so it's better to replace it. Because in case we might get some error with our sensor, it's why our data so weird at the beginning. Because I changed maybe a lot of time for that. For the suggestion, for the first, we should to make sure we should to make sure if our sensor in good condition before we start collecting the data. And then the second, considering the error data, since the sensor is installed outside the room or outdoor, rain or water will be an easy issue on this measurement. Therefore, a good design of covers is needed to keep it away from direct water contact. And then the third, optimize the power consumption by reducing the frequency of data transmission. And then the fourth, use the feature of sleep mode and set the wake up time in Arduino code to extend battery life. And then the last one is use the solar panel, because we don't know why the solar panel like useless over there. It cannot charge automatically.
Really?
Yes. I don't know how it's in your group. Is it can charge automatically from the solar panel?
I'm not sure.
Is the solar panel can work?
No.
Yeah.
Neither you. So how about your group, the solar panel? So you just use the battery.
Yes.
So means that the solar panel not functional.
Yeah.
Only the battery.
So when
all the solar panel
Yeah.
not functional.
Yeah.
Why?
Yeah, now I'm curious about that, and I still trying our rooftop
Okay,
to
maybe
test the
it
power.
should be okay because unless all the all the conjunction of the USB port failed.
Mm,
I'm not sure, but we can check out.
Yeah.
So all of you using the battery
yes,
only. Okay.
and also the other something is the sometimes suddenly turn off. Yeah.
Those are the conductors.
You mean that the normal power supply?
I think so, whether it works, but the link between the battery and the solar panel.
Okay.
It's the another issue.
Because I buy like the battery because it is provided a function for the very small current, like the Arduino. Okay, for the usual battery, sometimes you will find that when you plug the Arduino, but maybe after 1 minute or 2 minutes, no more power supply because the battery, some of the chip in the batteries will check out it is you already connect to the Arduino or not, connect to the something or not. But when you connect to the Arduino, but it is use a very small current, electrical current. So sometimes the battery will say that there's nothing connect to the battery, so it will automatically shut down. But for this new one, I buy this new one. It already have a function to detect the very small electrical current. So, but still sometimes
Suddenly turn off. So we need
so you need to manually
turn on.
Okay. Wow. Okay, so seems like the battery is now actually very well to the okay. So okay, because I think this is for the project purpose. In the field, actually, we will use the battery, the original battery, okay, and with some of the charger. Okay, so maybe we should replace with that. Okay.
With original battery.
No. The real battery.
Oh.
Okay, maybe like the use for the motorcycle is a huge one, battery, and also we need to buy some of the controller, okay, from the solar panel to directly to the battery. Okay, sometimes in practice we will use this for the power supply. Okay, so the Xiaomi battery actually not so good. Okay, I'm not sure. I just heard from your experience.
Now I'm still trying to do in our rooftop.
Okay, you can try to check out. Okay, very good.
Okay, thank you very much.
Okay. I think yes, this group use a filter, okay, to fill out the noise, and this will be a good implementation. Okay. So next one. 那个谁还没来啊？啊？他完全忘记了吗？你们有联络到他吗？啊，还没有请假。 啊，还在睡觉？
我也不知道。
不会那么离谱吧？
因为我早上有密他，他眼睛还没一睁。
哎，你们是这个嘛？哈。好吧，你们两个代表拍一张照片。好，等一下啊，1、2、3。好，来。
大家好，我们是第4组，那这边是我们的期末报告。那我们的目录这边主要分4个章节，日序论跟我们的 sensor， 还有我们分析跟结论的部分。那我们也知道，就是因为全球气候变迁，然后的问题，所以我们极端气候的强度跟周期性有持续在增加。那我们也是希望用持续监测，需要用到智能防灾部分来进行未来的监测。然后我们用 Arduino， 它可以用很多不一样的器具，然后也可以也可以设计一些 code， 然后它可以直接用我们的智能手机查询的部分。那我们就可以很轻的知道我们现在那我们这边主要使用的也是 DHT 温湿度的部分，还有我们3轴跟 GPS 的模组。那我们 DHT11， 那它这边可以应用到的温湿度跟范围都还蛮符合台湾目前平地上能使用到的那个范围。那我们这边也许用 code 跟我们所得到的资讯大概是长怎么样，就是可以直接明确知道我们的温度跟湿度。那3轴的部分，我们这边能侦测到比较就是最低的数值，可以到0.25度的变化，那是对于我们这个测量是还不错的。那我们这边可以就是用这些 code 可以直接得到我们 XYZ 的变化数据。那这边是我们用的 GPS 是 NEO6M 的部分，那它这边可以用这个 code 获取到的数据是大概长这个样子。那我们后面再介绍一下它所分析来的数据。那我们这边可以得到比较的资讯，就是我们 UTC 的时间，还有它的经纬度跟 WGS84它的那个范围的高度，然后还有它侦测到卫星的数量跟它的那个第几笔资讯。那我们这边获取 GPS 资讯的方式，我们其实是我们是用 Python 的 code， 然后把它直接读取、直接抓取。因为 MQTT 跟 TeamSpeak 的问题，所以它没办法直接上传到 TeamSpeak 让我们抓取，所以我们这边是试着用 Python， 然后直接抓取它目前获得的资讯。那这边是我们得到的那个经纬度。那我们尝试把这个资料丢回去，就是丢回去 Google Map 的话，我们会得到这样的数据。只是我们是在同一个定点执行的部分，然后我们是在就是标注的地方进行 GPS 测试，但它大概30公尺的位置，然后执行的这一块。那我们这样的测试会发现，这个 GPS 的模型是没有办法应用到我们监测坡地，没办法跟我们的3轴坡地进行一个搭配，因为它的精准度可能不太准确。那这边是我们获取资料的一个状况，对，然后它就是温湿度跟经纬度。那3轴的部分，因为 code 的关系，我们把它隐蔽住，就不要让它同时显示太多的资料，会有点混乱。这边是已经就全部整理到 LoRa 的 code。那这是我们主要也是用 MQTT， 然后 Node-RED 上传到 TeamSpeak 下载。那只是 GPS 资料，我们是用 Python 的方式直接抓取到 Excel 进行原理。那这边是我们的模型跟我们用的测站。
你们这个放在哪边？稍微 put your
有这个吗？ 其实我们原本的组别是在就是新架设那一组，只是我们后面因为器材使用的问题，我们就是拿回来测试的时候，然后其实当时只有3组可以用，然后我们后来去测试的时候，我们的天线其实有被拔掉，所以我们的资料后面其实有比较少，会有比较少，因为中间中断，然后天线也不够使用。然后这个是我们资料的图，可以看到我们时间上有许多缺失值，然后还有一些天数是没有资料的。然后这就是我们温度跟湿度还有3轴的资料。然后我们主要是用STM 的神经网络模型来做分析。然后这个是如果是 AN 的话，它是用权重来做预测，然后 RN 的话，它是可以用以前的资料来当做权重来做进行的预测。我们它是可以决定那个时间序列可以多长。然后我们主要是拿那个温度来当做例子，然后温度与湿度来当例子，然后去做一个分析，有用 R-square 跟 MSE， 就是 mean square error。然后这个是我们在 Python 上执行的code。然后这个部分呢是温度的资料预测，我们 training 的时长是从15号到19号，然后测试的时长是19号，但是没有一整天，大概只有十几个小时这样子。然后可以看到我们 MSE 的资料结果是0.13，然后 R-square 是0.93，是还不错的。然后这个是我们预测的结果图，可以看到我们预测的结果图，我们预测 training 时间是15号到20号，然后预测的时间是20号到21号，可以看到它其实没办法预测一整天的时间，到后面的时候就已经对了。然后这个是湿度的资料预测。我们是拿15到19号当做training的时长，然后也是19号到19号的下午来当做测试的时长。然后我们的 MSE 跟 R-square 就比较低一点，它 MSE 是0.0，然后 R-square 是0.78。然后可以看到它的预测图也是没办法预测一整天这么长的资料。然后我们的结论就是，因为我们有许多给大家看这个，因为我们有许多的资料缺失，所以可能是仪器更新率的不稳定，以及 No-Ray 接受 MQTT 的资料不稳定造成的原因。然后以及不同的时间解析度导致我们有高低近高低消的情况发生。然后即使 LoRa 同时传输数据的时候 ，TCP No-Ray 也无法同时接收数据，
就导致我们原始资料的时间间隔不一，就可以看到像在分的时候是一样，只不过它后面毫秒的数字呢没办法达成一致。对，谢谢大家。
Okay. So it's a very good at using AI for the prediction, but I think because of the limit of the data, so the prediction cannot not work. Okay, but it is a good trial. Okay, but I would like to say, can you go back to the last page? Okay. So it is a data from the ThinkSpeak. It's a downloaded from the ThinkSpeak. So there's a some of the time delay.
它没办法，就是三轴它应该是同一笔数据，但是它对它会分开，可是我们在抓取资料的时候是同时，只是我们在想。
So what is the time interval? And you use 17 second. Okay. So 你们的那个时间间隔是多少？
就我们在设 code 的时候，
对，就每一笔做传输。
我忘了那时候，因为我们有调整过啦，所以后面我们调的比较近一点。可是我们把间隔时间拉长的时候，它还是一样是这个状况。
你们拉到多长？他们感觉是有测试17秒以上
就可以
收得到。
那
你们是不是太快了？
应该是太快了。
I think they use too higher frequency, okay, to transmit the data. But I would like to say, because we are using the monitoring the slope, not the dynamic behavior, so maybe we don't need to use the so much higher frequency, sampling frequency. So maybe 1 minute, it is enough. Okay, if you try to monitor a long-term behavior of the slope. Okay, so 1 minute or 2 minutes or 10 minutes, it is enough. Okay, but it is a good experience because right now we have a limitation. One is from the LoRa. Okay, so when you try to transmit the message through the LoRa, maybe 5 to 10 seconds for the interval it is needed. Okay, and then another limitation is from the ThinkSpeak, because it's a free version, so we need to wait maybe more than 20 seconds. It is for sure. Okay, for your data upload. Okay, so maybe you can try. Okay, to extend the sampling interval. Okay, good. Okay, thank you very much. Okay. So I think we are already finished the presentation of the final project, and I would like to expect it using your module in the field for the real long time monitoring. So, but I think you cannot install because you have to go back today. But I would like to ask Barry and another student, and also the Rick TA, to help us to install all of your equipment in the field for the long time. And I would like to merge all your experience, okay, and to find an optimal solution for the monitoring in the field. Okay, so please, maybe Ferry and Yankai can help us to extend the project for longer. And final, I would like to ask all of you to check out the EE class platform. I think some of you already done with the questionnaire. Let me check. I have the same questions in the beginning of this class, right? So please help me to answer again the questions after you already learned from this course. Here, I think we have pre-questions in the beginning of this class, and final, please help us to finish the post questions. The same, I think the same, but you can answer that based on your what you already learned from this course. Okay. Again, what is the disaster prevention, and what is the monitoring, and what is the principle for the monitor plan? What is the 3 R's? And finally, what have you learned from this course? Okay. So wish you have a good summer vacation, and please keep yourself, because I know that someone will go to the mountain or the beach. But okay, please take care of yourself, and also we will keep in touch in the future. We already have the line group, so we can use the line group to communicate always. Okay. Thank you. Bye bye.
Yeah.